Welcome back, Curiosity Beasts. If you haven't watched part one yet, stop right now and go watch it, because what I'm about to reveal will make absolutely no sense without that foundation. And trust me, you need your mind properly warmed up for what's coming. In part one, we discovered the impossible. 13.8 billion year old light that has somehow traveled 46 billion light years through space. That breaks the most fundamental law of physics. Nothing can move faster than light. So what's going on? How is this possible? The answer to this cosmic mystery lies with one man, the greatest mind in human history, Albert Einstein, and the catastrophic mistake he made about the universe that would haunt him for the rest of his life. In the early 20th century, Einstein was developing general relativity, the instruction manual for how the entire universe works. It described how space and time are woven together into space-time, how gravity warps this fabric, and it established the cosmic speed limit, the speed of light. But there was one massive problem. According to Einstein's equations, the universe couldn't be static. The force of gravity would eventually pull everything together into one massive cosmic pile. The universe would collapse. Einstein hated this. And pretty much every scientist of that era agreed that the universe must be eternal, unchanging, and static. A perfect, unmoving sea of stars that had always existed and would always exist exactly as it was. So Einstein did something scientists are never supposed to do. He cheated. He inserted a new variable into his equations called the cosmological constant. This constant behaved as a repulsive force, a kind of anti-gravity in empty space, designed to balance gravity and keep the universe perfectly still. It was elegant, it was clever, and it was completely wrong. But here's the twist. Einstein was wrong about the static universe, but he was actually right about the cosmological constant. The universe had a much bigger surprise waiting. In the mid-1920s, Edwin Hubble shattered everything the scientific community believed. Up until this point, astronomers thought every point of light in the sky was a star in our cosmic neighborhood. Those fuzzy, smudgy things they saw? Just clouds of dust and gas called nebulae. The biggest and brightest was Andromeda. Hubble measured its distance by spotting a Cepheid variable star inside it. These stars pulse in a regular pattern, and by measuring that pulse, you can determine their actual brightness. Hubble found that this star was incredibly bright, but appeared extremely dim through his telescope. That could only mean one thing. It was impossibly far away. His conclusion was revolutionary. Andromeda wasn't a cloud of dust. It was a gigantic system containing billions of stars, an entire galaxy. And it was completely separate from our own Milky Way. This was humanity's first proof that galaxies exist. Less than 100 years ago, we didn't even know there were other galaxies. But Hubble's next discovery was even more shocking. These galaxies weren't just sitting there, they were moving, and they were all moving away from us. Working with Vesto Slipher, Hubble noticed that light from almost every galaxy was shifting toward the red end of the spectrum. Red shifted. This is the Doppler effect. You've heard it with ambulance sirens. As the ambulance approaches, the pitch is higher. As it drives away, the pitch drops. The same thing happens with light. If a galaxy moves away from us, its light waves stretch out and shift toward red. And here's what changed everything. The farther away a galaxy is, the more red-shifted its light becomes. The farther away a galaxy is, the faster it's moving away from us. This gave us two fundamental discoveries. First, space is expanding. The universe is getting bigger. And second, that expansion is accelerating over time. It's getting faster and faster. Einstein's static universe was proven completely wrong. But his cosmological constant? It was real. We now call this force dark energy, the energy of empty space. And it's the stronger force in the universe. It's winning the cosmic tug-of-war against gravity. Dark energy pushes everything in the universe away from everything else. And here's the key. The more empty space between two objects, the more dark energy pushing them apart. The farther apart they get, the more empty space appears, which means even more dark energy, pushing them apart even faster. It's a runaway feedback loop. Comment below if you think dark energy is the key to understanding reality itself. Now here's where things get absolutely insane. The speed of expansion can move faster than the speed of light. Einstein's rule still holds. No matter can move through space faster than light. Your body, a spaceship, a planet, none of these can break that speed limit. But space itself? It doesn't care about speed limits. The fabric of space-time can stretch and expand as fast as it wants. This is how we solve the impossible equation. Light itself travels at a constant speed, but the space it's moving through is expanding. Imagine walking forward on a treadmill that's moving backward faster than you're walking. You're moving forward, but you're going backward relative to the room. That's light in an expanding universe. The journey takes 13.8 billion years, but the expansion stretches that into 46 billion light-years of distance. Now we need to completely reimagine the Big Bang. Everything you were taught in school is wrong. You were probably told the universe began as a cosmic egg, a single point that exploded. That's incorrect. The universe didn't expand from one single point. Remember the cosmic microwave background from part 1? That ancient light surrounds us in every direction. It's not coming from one point. It's coming from everywhere. The Big Bang didn't occur in one location. It happened everywhere, to everything, all at once. Every single point in the universe experienced the Big Bang simultaneously. Let that sink in. During cosmic inflation, space expanded so fast that an area the size of a grain of sand grew to the size of an entire galaxy in less than 1 second. If the pre-Bang universe was a sandbox, imagine every grain of sand simultaneously expanding to the size of galaxies, all at once, in the blink of an eye. Drop a comment if your brain just exploded, because the Big Bang wasn't a bang. It was everything, everywhere, all at once. Expansion on a scale human minds cannot fully grasp. And here's the final revelation. This expansion is still happening right now. The space between galaxies is growing, the universe is getting bigger, and the expansion is accelerating. Distant galaxies are moving away faster and faster. Eventually, billions of years from now, they'll be moving so fast their light will never reach us. They'll disappear forever. Future civilizations will look up at a much emptier sky. We're living in a golden age of astronomy, when we can still see much of the cosmos before it disappears beyond our horizon forever. So let me ask you this. If space can expand faster than light, and if the Big Bang happened everywhere at once, is there really an edge to the universe at all? Or are we just observers trapped in our own bubble? And if we can't see beyond it, does it even exist? These questions keep the greatest minds in physics awake at night. We don't have all the answers yet. But that's what makes this exciting. We're living in an era of discovery, uncovering the deepest secrets of existence. If you made it to the end, you're officially a true curiosity beast. Hit that subscribe button, smash the notification bell, and drop a comment telling me what topic you want us to explore next. Black holes? Quantum mechanics? The search for alien life? Let me know. Thank you for joining me on this journey to the edge of everything. Keep questioning, keep learning, keep feeding that curiosity. The universe is far stranger and more wonderful than we ever imagined. I'll see you in the next video, Curiosity Beasts. Stay curious.